In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/detectify. Go hack yourself. By connecting to your code repository, AccuRx generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, AccuRx develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with AccuRx at securityweekly.com/AccuRx. Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by visiting securityweekly.com/guests and completing the form. We review suggestions monthly and will reach out to you once reviewed. In our October 22nd technical training, we will provide a first look at a new free resource that delivers thousands of remedies as a service to bridge the gap between vulnerabilities found and vulnerabilities fixed. Visit securityweekly.com/webcast to see what we have coming up, or visit securityweekly.com/on-demand to view our previously recorded webcasts. And that brings us to some news of the week. And the first one I have to introduce for you, John, that you brought us to, mostly because I just wanted to say Domos arigato, Mr. Roboto. What is this particular one?
Yeah, this was a fun one. And yeah, I've been pulling a lot from Full Disclosure the last few weeks. It's one of the mailing lists I've always read. This in Bug Track. They're sort of one of my sort of morning, we have our routines in the morning. This is one of mine is going through what came out last day or so. Domos is a hardened operating system. And it looks like the company behind it, they're doing some sort of open source applications as a product type thing. So they sell boxes with some of these things on there. And they decided, I'll leave it. I'll try to leave my color commentary out of it. They decided that they want to run this on a hardened operating system, and that part makes sense. But it turns out, said hardened operating system, they've taken some version of Linux. I want to say Debian based, but they've taken a version of Linux and they've hardened it. As you know, hardened operating systems used to be one of my passions. So again, I'm leaving my color commentary out, but you can probably guess my thoughts. In this particular instance, they've got a admin web interface which runs as root and runs Python scripts. Said Python scripts take user input and do that little plus thing and paste it into the actual command being run. Generally considered not good. This was found, and they found a few vulnerabilities or a few issues based around that, and hopefully those guys are going to clean up and make this stuff a little better. But that sort of caught my eye, right? I try to find things here that aren't just the really cool, really deep, oh my God, how much time does someone spend to figure out that there was a vulnerability in there, right? Intel microcodes type things, but just looking through a basic script and going, hey, you're taking something that you just got from a user in an input field and you're appending it to a string and you're passing that to system. So we're not all at the same level, but some of these things for some of our listeners are good to remind that, hey, this isn't good to do.
Just standard input validation at this point, yeah. Right? Even totally. In a hardened, secured OS, obviously the admin interface needs root permission, so I can't use my no root comments, but you still need to do some level of input validation to make sure you're not allowing, something malicious to happen, which is how they found this one.
I think the question we can still.
Go ahead, John.
Well, quickly on that, I think you're about to say the same thing. The question of if you need root for the admin interface is becoming more and more questionable, right? I mean, maybe you could run admin itself as non-root, and then have some sort of sudo thing which only allows a limited number of commands, or there's all sorts of ways you could do the input validation on this.
That's true.
Yeah, absolutely. And that was the direction I was going, is that you don't need root to run all the commands. You just needed to run a couple of predefined. You actually probably even know exactly what commands need to be run. And those you could narrow down to a allow list that execute these as roots, sudo them, or do something else. The other thing, and just to kind of reinforce John's point about this was just a really classic and simple type of vulnerability, because the command injection was as simple as add a space, put a name, and then the name of the command you want to run, and then semicolon delimiter from there. So it's not even just input validation, and that's why I'd sort of even harp on that. It's more of use your argument passing to the command you were trying to execute in a smarter way. And in this case, this is Python. Python has those capabilities to build up the flags that you're passing on to a command. And so there's a lot of ways, if we were just have a more generic threat modeling conversation around this type of vulnerability, there's a lot of different paths we can go. And so it is really great to see these types of so-called simple vulnerabilities that are easy to exploit, but have kind of some rich conversation behind them, I think.
Yeah, and the one last thought on this, it's, well, I don't want to, I know nothing about this vendor, know nothing about if they wrote these scripts themselves or maybe got them somewhere else, but a little bit of the marketing salt going on here, right? Just because someone says they're giving you a hardened operating system, I feel for folks who put this in production in sensitive areas, do a little bit of testing of this stuff first.
Definitely do a little bit of testing, and a little bit of testing is also what another vendor, which I wasn't familiar with, but linked to a advisory from Tenable that did some fantastic research that basically took what looks like a modern application and pulled it apart with all of the vulns from 20 years ago, all my favorite ones. It has SSRF, it has CSRF, it has cross-site scripting, and, drumroll please, directory traversal, several flavors of directory traversal, even as simple as just going .. etc password. So there wasn't even things like having to drop a null character or some other terminating character in that %00 into the URL, or poke around something fancy. And to me, it was, again, in that spirit of, we don't want to over-index on the really complex vulnerabilities like you were describing all the time, John. It's really good to have some simple examples, because here is a way of just show this to someone who wants to learn web application security, because this write-up is really nice in terms of just showing how easy it is to put together some payloads. And maybe you need some burp proxy or Z-attack proxy to do some of these payloads, but for the most part, you could just do this in the URL. All you really need is a browser, and you could pull off a lot of this testing and a lot of really impactful, find some vulnerable vulnerabilities in here. So interesting, appealing to me from that aspect.
Yeah, and if you want to understand how a vulnerability disclosure timeline and stuff looks like, they do a really good job of documenting the entire vulnerability disclosure timeline and process. I think they did a really good job documenting not only the vulnerabilities and the exploits, but also the whole communication back and forth with the vendor. This is a firmware update required to fix a lot of this stuff. It just kind of shows you how these vuln disclosure programs should work.
Indeed.
Yeah, that's cool. And it's actually, the funny thing about this one, I'm not sure funny is the right word, but the interesting thing about this one, how about that? We'll edit it in post, is this just keeps going. And it gives you the warning up top. It says, hey, multiple vulnerabilities. But usually when I see that in a report, I expect one or two things. I'm like, okay, cool. Then it's usually sort of ... You might want to update. There's more, but 1, 2, 3, 4, 5, 6 CVEs.
Yeah, in 4 major classes, right? Yeah, 4 major classes of vulns. Yeah.
Yeah, it's across those multiple classes that just stood out to me as we had a great conversation with Chris, but we definitely need Chris to go do a lot more conversations about security awareness and building up more champion programs, because
simple threat modeling might have caught a couple of these. I'm just saying.
Yeah. One hopes. Which, in addition, is a way of slightly more advanced threat modeling, but still some pretty simple concepts. There was a presentation out of Black Hat Asia that was focused on cross-protocol attacks in mobile communications networks, talking about 2G all the way 2, 3, 4, 5, and 5G. And unfortunately, if you thought that we were throwing together way too many acronyms last week when we were talking about the cloud controls matrix and the egregious 11, the slides that are linked to in this article has quite a few of their own acronyms. But I think the more important thing here in terms of how to use this to start a conversation is, great, we've gone and created 5G, we have some new protocols, but we still have this whole existing backlog of devices. Call them mobile devices, call them IoT devices, call them old versions of Windows. There's a lot of parallels here throughout, in many different domains. And there are either creakiness in supporting those old versions, or the way they interact with each other, suddenly there's a security assumption or a security barrier that gets lost in translation between these protocols. And that's also what we saw with Bluetooth. So I just thought this was a really great theme in that sense of security isn't so easy, or engineering isn't so easy just to say, yep, we're only supporting this one version. We suddenly have to support 2, 3, 4, and more. And that's where a lot of complexity comes in, and insecurity.
Yeah, what I like about this article is it points out the fact of the SS7 protocol, which has been around for a long time, since 1975. And a lot of people, when I was at Tenable, we did some research here. There were some products that were emerging really to look at the mobile network and in the what's it called, Signaling System 7 protocol. Mm-hmm. And, a lot of people were like, oh, okay, but that's only your phone. 5G changes this dramatically, because you see a lot of discussions going on about wireless access through 5G as these 5G networks come online. And I think you're going to see a lot more connectivity, but SS7 is still kind of this historical old protocol in the background that no one's really been paying attention to, that it's going to surface its ugly head, as it did here a little bit in this presentation. So it'll be interesting to see, how people look at some of the issues of new protocols and the ability of backwards compatibility with SS7 protocols that are going to have some security implications, I think, for 5G as we move forward.
Yeah, the timing on this was interesting to me. Last week, I was paying attention to the Linux Foundation had their, I keep calling it WONS, the Open Networking Edge and Open Networking and Edge Summit. And yeah, I mean, it's basically the networking stuff around Linux world. Linux Foundation. Hello, can I speak? Guess not. But one of the things that, telco has their own language. I've spent some time there in the past, and even coming back to it, SS7, like, oh my God, these things still exist. But, really rehashing what Matt was just saying, this is, I don't think most of us fully understand how much 5G is coming back. We think 5G and like, oh, it's just the next phone thing, right? There was some really interesting talks in there last week talking around if they want to hit the goal of what they're trying to do of having these little IoT things. I'm not even looking at an IoT point of view, just in general. But if you want to have something that is smart and responsive by itself on the edge of your network, you need not just a fast network, but you actually have to put those things on the edge, because if you actually look at the buildup of time, airtime plus routing and switching time plus getting over to your cloud and then spending some time there to actually get the latency down to something which is, I'll say, human friendly and really reactive when someone's actually using it, you have to have that stuff at the edge. So a lot of those type of things, I think we're going to see more of focus around security on 5G and the different parts of it. So I think this is the beginning of that.
Yeah, great points all around. The idea that, we still can't beat the speed of light. So latency is always going to have some pretty hard boundaries. So there's that aspect of moving to the edge, having a lot of, call them just tons of little devices. They can be IoT, but what vulnerabilities does IoT have already? Can we update those devices? And then how many of them are talking just 5G or just these protocols? And how many of them are having problems in just Bluetooth, for example, then can we even update them? So I think then switching from the pessimistic side of things, when all the vulns are out there, there's actually some optimistic news that we have this week. One is Microsoft. Well, GitHub is putting code scanning into their making it available. I mentioned Microsoft because they're really, I think, successfully leveraging their acquisition. So here we see GitHub, SEML putting two things together that are basically finding, let's get, I'll just say simple mistakes, simple coding mistakes, simple linting, which I think is the most important to get started with. But GitHub's going to make it a lot easier to find more complex as we go types of code quality issues. And I think that's just a fantastic move because it's putting it right in front of developers. Yeah.
I mean, GitLab has similar capabilities, but you see Microsoft now really leveraging this acquisition to bring some of that capability into GitHub as well.
Yeah, I'm still trying to wrap my head around this one. I can see the stumbling. I'm still not thinking of it as scanning. When CodeQL came out, I don't know if you guys have played with it. I think of it as it's QL. It's a query language. Where does this issue exist in your code? So they're taking that framework with, I forget the number. I saw this last week. 200-ish, 300-ish rules they've defined in there, I think. And then being able to run that on commit and sort of show you, here's what's missing. I mean, I guess in a way it's a scan, not the way we usually think of it, not the way I think of it. At the end of the day, though, is it going to help people? Is it going to actually get some of those basic things out of the code? I think that's what's going to be interesting to see. This is, I think what's interesting about it to me is, I don't think it's on by default, but as they get closer to that and being able to just, as someone checks code in. I mean, I did which tool was I using last week? Sorry. It was Dependabot. And I think I might have mentioned this previously, but when I did a git push on something last week on one of my projects, and that had an issue with Dependabot, and part of the commit message coming back said clearly, it's like, oh, by the way, there's a problem with your code. So I didn't even have to go into and it was, I guess it's a commit hook on their side, not on my side, but I didn't even have to go into the browser just to go and look at a report. It just came back and said it right at me. So I think as we do that more and more, and it probably took me a few pushes to actually notice it, right? Because you do push and you go off to another window. But I think as we get closer to that and make it more visible to people, people might get, hopefully might change the way they think about some of these things, developers, and start approaching it a little bit differently.
Yeah, I think you're touching on a good, go ahead.
I was just going to say, they talk about some of these stats in what they've seen so far. And one of them is that 72% of the bugs are being fixed in the first 30 days because of this notification. To your point, John, right? If that now means more people are fixing them faster because they're being notified as these requests and pull requests are getting taken care of. That's a good sign, right? Yeah, there's still 28% that needs to happen. But I think having that visibility and getting it into the developer's hands faster is what we really see as kind of the value for DevSecOps and letting the developers, fix their stuff faster.
It is. And I think there's still an underlying aspect here is that a lot of this is what kind of like query language. It's looking for these problems that you know of. And so it's sort of like, oh, we had a bug bounty report in this type of pattern. Where else in our code might this be? Or these group of developers are making this mistake. Is everyone making this similar mistake? And the point I'm getting at here too, we had a good conversation with Chris. So he's kind of saying you can't necessarily test yourself to security, or you can't, like pen testing. So this isn't going to suddenly say your code is secure. What it's going to help you better do, which is still good, is that you're making fewer mistakes that you were making in the past, or you're making the fewer mistakes that others are making as well. But there's a lot of still other problems that can happen that the CodeQL, the nature of this type of, call it scanning or just linting, isn't going to find. So very important step. It's a great thing to highlight to developers to get that security-minded thinking. But by no means should we think that all of our directory traversals are going to go away just because of this. And that also now we have, speaking with this episode brought to you by the letter G, because we go from GitHub to 2 articles about Google. One talking about launching their Android partner, a program to basically look at all of their partners within the ecosystem of Android devices. And what stood out to me here is more of just they're kind of acknowledging that there is call it a problem here, that if you get a Google curated handset, a Pixel, you're probably going to be pretty good with getting patches, with what the security model looks like, but all the other vendors might not have the same quality associated with it. And so they're just saying, we're going to take on a little bit more responsibility and start to finance and hire on to our team to not only look at that, but look at other vulns within apps within our app store as well. So on the Android side of things, I thought that was pretty interesting.
Well, I think it's a necessity. We've seen a lot of specific platform breaches here on the Android side. And so if you're Google and you're trying to build out a secure ecosystem, you have to look at the OEMs and the hardware platforms that are out there. Otherwise, you've got a big blind spot.
Yeah, so maybe there's a good way to describe, that responsibility of security and working with the developers, in this case, investing their own money into protecting the OEMs. And the other article is sort of a companion piece to the Android side of things. This other one about they're setting up a research grant for fuzzing. And in this case, they're fuzzing specifically JavaScript engines. But what was interesting to me is that last week, or maybe it was the week before, we talked about some Chrome patches that were roughly $50,000 for a half dozen or so high and medium vulnerabilities. In this case, they're basically saying, here's a $50,000 pilot program that we want to give to some researchers, some universities, to go and fuzz these JavaScript engines. So looking at that, not so much from a security, what are they going to find, but from a investment perspective, where are we going to spend our money? And maybe spending $50K on just the bug bounty from external researchers randomly looking for items will be helpful. Or maybe that $50,000 could be focused on fuzzing that could give us a richer amount or maybe a richer quality of vulnerabilities, or even just crashes that are just code quality things that we should fix that don't even lead necessarily to a security compromise or an exploit in our JavaScript engine.
Yeah, 50,000. I think 50,000 is about a week at GCE. I'm kidding. What was interesting about this, and I really do want to try and get my hands on this thing, was, and I missed a few said it there, Mike, sorry, but it looks like the fuzzer that they're using has the ability to, or at least my interpretation when I was reading it, is to be able to look at code coverage, test coverage, and then sort of fuzz where that coverage isn't. Was that an accurate read?
Yeah, I think so. And that's one of the things here, then why I kind of skipped over this, but focusing on the JavaScript engines is that those are pretty complex to test. It's not so easy as I'm always harping on saying, cool, here is a compression algorithm. Here is an image or a media processing algorithm that's a pretty well-defined type of file format. JavaScript is quite complex, and being able to effectively test those, so you're getting into paths that are useful, that might turn into crashes or security-oriented crashes. You can spend more than the $50,000 of Google compute time just on all kinds of paths that aren't going to do anything. So that's really what this is emphasizing. How can we be smarter about applying and guiding our fuzzers as opposed to just fully randomly throwing it at that in these JavaScript engines, which are a notorious area for vulnerabilities? Because I think I was trying to look for some other stats. I think this was an article from chromium.org back in May 2020, and they were saying that the Chromium project still finds about 70% of their serious security bugs are memory handling, which are essentially heap overflow, stack overflow, those off by one, beyond the arrays, or things like that, that ideally fuzzing is going to help them find. So in that case, still a good investment to go after what is we could call a brittle code base in the sense of memory safety.
And I think that sort of reflects, sorry, really quickly, I think that reflects what we were seeing earlier this year from Microsoft, right, when they're looking to move some of their stuff over to Rust. So it's nice to see a little, there's multiple ways you can think about memory safety and say, okay, we can either do like use a tester like valve grind, to actually try and track down some of this stuff. Or you can actually, hey, let's try and actually move that sensitive part of the code somewhere else. So it's nice to see this getting some attention. Matt, I'll stop interrupting you now.
But it's interesting how this is getting paid out, right? These grants are getting paid out as credits on GCE, which tends me believe they want you to use GCE and their open source tool to run this. So the question is, when do you run out of money from your grant because you're using GCE properties to actually maybe do the fuzzing? It's just an interesting way that this has been put together. Is there credits, not necessarily payouts, on Google's infrastructure? It means all the educational environments that are using GCE are perfect candidates for this, but I'm not sure most people are going to see this as valuable just because of how it's being paid.
Good point. And even so, OneFuzz, for that matter, was all on Azure, and the whole aspect of OneFuzz was make it easier to manage the life cycle of the fuzzing, crash, and analysis process. I think pointing out this pain to credits is this is still kind of that underlying conversation about bug bounty security research. Is that, and even I think in their article, the article here was saying that a lot of the researchers aren't doing necessarily fuzzing for this on their own because it's time intensive, it's compute intensive and memory intensive. So it's hard for a researcher to say, well, I'm going to front a few hundred or a few $1,000s and maybe find or maybe not find a vulnerability, or hopefully at least find one that's not a duplicate, because the bounties are going to pay for results, not for work done. So there's still also, speaking of incentives, as we were last segment, there's still a matter of incentives that I think all of these companies are trying to figure out. How do they get external researchers to focus, but still actually pay them for their effort and continue to garner that effort?
Yep. Yeah.
So there's also one other thing. So we also mentioned very briefly Cloudflare next week, and they've been, I think, going through their 10-year anniversary, announcing a lot of things, a lot of projects. And one that did come across my radar was they are talking about API Shield. So pretty interesting. And as they note, I think this is no surprise, is that APIs are driving everything. We're talking about, we could talk about web applications, but every mobile application and even IoT device really is just throwing back and forth, possibly JSON blobs to a backend API sitting on one of the clouds. And so in this case, it's highlighting a couple ways of securing, and I call it a high concept. We can do that rather than just the specifics of what the particular company's offering is. One, mutual authentication between devices. So already that's one of the things that can be easily done within an organization because you control all the PKI, you can control certificate handling. It becomes a little bit harder when you start to figure out, well, what about all of our devices that are mobile apps and so on? So just anything that can make PKI easier, because that's been call it a silver bullet or desired silver bullet for at least a couple decades, I think. So it'll be nice to see if that gains good traction. And the other thing is the schema validation. So this is basically saying, rather than try to figure out that what does garbage data look like, or what does attacker data look like, how are people abusing my API endpoint, let's just say, this is the actual communication that is supposed to be coming into my API endpoint. And anything that's not really matching up to this schema, basically input validation, let's just reject it. And so that more positive model, there's an assertion there that can be more effective, that can just be easier to deploy and catch items that are potential attacks. So two ways of either looking into API Shield if you want to adopt it, or just taking those two particular concepts of mutual authentication and hardening an allow list against your schema, and to that. And I'm sorry, running out because I'm ranting here. Running out of energy there. Two great ways to think about building your APIs. Matt and John, help me out. Save me from talking too much.
Well,
laughing isn't helping, John. Laughing isn't helping.
Helping me.
I mean, I love the concept here, right? I think certificate validation is great, and then they're doing the whitelisting on the schema, right? I'm curious how well the whitelisting for the API schemas work. based on how well the APIs are documented, right? So it'll be interesting to see, does it actually work as described? Will it be effective? Because I either do or don't have well documented API schemas. I think the downside still is abuse, potentially, like valid abuse, where it doesn't look malicious as a valid schema call, but now you're trying to do something where you're trying to overrun an API or drop the back end or something like that. So I still see a couple areas that you could still have abuse, but maybe this is a good starting point to just protect against aspects of malicious behavior that are kind of known malicious behavior aspects.
Yeah, it's definitely going to help. I would imagine, as the planets align and things go positive, I can see how it's helping against a lot of just input injection type of attacks. But you make a really good point that there are multiple ways a system can be abused. And they do talk about credential stuffing. Credential stuffing still, it's not an injection attack because you're using conceptually, what could be a valid password, a valid username. You're just trying to figure out, is that combination of username and password correct? And especially if you're go into the fintech space or anything that is dealing with credit card numbers. There's a lot of ways to abuse endpoints that are accepting credit card numbers to figure out just if attackers have a stolen dump, is this a valid card? Or how can we just figure out and enumerate what's the 3-digit CVV for it? Or what might be the expiration date, and do a lot of submitting what is actually valid data against the schema, just submitting that on a very high rate of requests as opposed to what might be a human rate of requests where they're submitting something one at a time. So great point that this isn't going to solve everything. Still lots of abuse out there to be concerned about.
Yeah, and that's where I see other solutions having done more around some of those different abuse scenarios, one of which sponsor Signal Sciences acquired by Fastly, which is going to compete in the same space with Cloudflare, right? How do those types of services evolve now? But you're going to see some interesting capabilities brought into some of these types of products where I think you can maybe address some of the other abuse cases. Just this doesn't address all of them. It's a really good start, but there's more to do.
I was going to say, this is sort of a sleeper blog post. I mean, when I first saw it, I don't remember if I saw it last week or reviewing the news here this morning. But you're like, oh, API Shield. Okay, well, they're taking their WAF that they've had, and they're just sort of using that on the API. Okay, cool. And then, I listen to you guys talk, and I dig a little bit deeper in here, and yeah, there's a ton of great stuff they're coming out with. And personally, as it put a smile on my face to see mention of CFSSL, their PKI toolkit. The last time or two, I've had to build a CA instead of trying to wrangle and deal with the correct, rolling up the dice to get combinations of the correct commands in OpenSSL. I much prefer to use CFSSL. So, if nothing else, I recommend folks go in and take a look at that. What I haven't dug into here yet, Mike, you might know, on the when it comes down to, where was it here? Back up a little bit, sorry. When it comes down to actually validating an API, is it learning what the API should look like, or does someone have to define? Because if it's the latter, then that's, as Matt said, still room for improvement.
I think you have to give it the schema for the whitelisting rule. So I don't think it has learning capability yet.
You know how hard it is to get a schema out of developers?
Mm-hmm. That's why I said, if it's a well-documented API, this is a great approach. But if it's not, what are you missing?
Yes, and that's where it's definitely going to start pushing on the maturity. And this is where I think, so the companies that are building APIs that are intended for B2B, call it B2B SaaS, or they're intended as an API first, they are possibly going to have an advantage here because there are movements like OpenAPI to try and help. Let's sort of standardize or build some expectations around how an API can be, I'll use the magic words of self-documenting, or have a much clearer schema. And something like this talks about JSON, and out of Google, many years ago, but still quite popularly used across many companies now, are like gRPC. TRB that has and protocol buffers that is actually pretty good at self-describing their data types and interfaces. So there are steps here, but it's definitely going to push on organizations to be more diligent about actually documenting their schema or using API design patterns that have a lot of this information in it. So it's not going to be so easy as a one-click that like some of their TLS termination would be, where you can get TLS 1.3 essentially for free. Going to be a little bit more work here, but I think hopefully the sleeper hit of something like this, or Signal Sciences, that this type of inspection, this type of controlling and looking at the schema and enforcing that, I think has a lot of really great potential benefit down the line. Yeah,
I just have to echo what you said and say I love open API. From the moment I found that, it puts a smile on my face every time I go to use it personally.
Yeah, so there's at least 2 out of 3 people are using OpenAPI on this podcast. We know we don't want to try to throw Matt into coding again, so we'll give him the benefit there. But I'm curious, let us know in Discord or your listeners, how many of you are actually using OpenAPI or adopting this? Because I would love to know just what the future looks like for projects like that.
And Mike, I just want to inform you that your impact on TLS version 1.3 has increased by 6. We're now at 34 instead of last week at 28.
This is wonderful. This is the impact that security awareness through a podcast like Application Security Weekly can have. So glad to see that there is strong causation in the correlation here, Matt. Thank you. You just made my Monday. And I think with that, we'll end on a high note, perhaps. And I want to say thanks to Matt, thanks to John, thanks to all the listeners who've been checking in. It's October, so we're building up to Halloween. Thank you for joining us, and we'll see you next week on Application Security Weekly.